The objective of this is first, help in creating an invention that is perfect for the use of humans. Next, making an object better.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafitri bin Rozaimi. My metric number is AA212145. Today I'm going to explain about the application of equilibrium in the seesaw. Seesaw is a long plank balanced in the middle on a fixed support. The children will sit on each side of the plank and swing up by pushing the ground alternately with their feet. But to achieve equilibrium of force on the seesaw, the plank firstly must be horizontal and perpendicular against the center of the seesaw. Furthermore, in calculation of statics, it will need another factors to achieve the equilibrium of force. Firstly, the net force acting on the object must be zero. Therefore, all forces balance in each direction. Then, the second condition necessary to achieve the equilibrium of force is involves avoiding accelerated rotation, which is maintaining a constant angular velocity, so that the rotating body or system can be in equilibrium if its rate of rotation is constant and remains unchanged by the forces acting on it. That's all from me. Thank you.
The application that I use for equilibrium of force is a portrait hanging on the wall. When an object is hanging on a wall, it is acted upon by a number of forces. The gravitational pull of the earth tends to pull the portrait in a downward direction. At the same time, the push force and the direction force offered by the wall keeps the portrait in place. These forces do not make the portrait change its position or state with respect to time.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Imran bin Mazal. My matrix number is AA211190. The application of equilibrium of force that I choose is vintage balance scale. A vintage balance scale consists of two plates or ball hanging on a fulcrum at equal distance. One plate carries an unknown mass, while the second plate is filled with known mass until equilibrium is reached. This relates to equilibrium of force because the mass that is on the plate refers to the force acting on the fulcrum, which is the object. When both sides of the plate have the same force acting on the fulcrum, equilibrium will be formed and the fulcrum will not move.
So, Assalamualaikum warahmatullahi wabarakatuh. My name is Hazi and I want to present about my choosing application about equilibrium of force. Okay, so first of all, equilibrium is summation force exactly balanced or cancel out by other force. Okay, my consider of application is gliders. Case of a glider. So the gliders have a three force acting. It is on the flight. So I have two example on my picture page. So example one, I show the computer drawing the glider as is descending. There are three force acting on the glider: lift, drag, and weight. The weight is always direct towards the center of Earth. The lift is direct perpendicular to the flight path, and the drag is along the flight path. The flight path is inclined to the horizontal at an angle. When aircraft is in equilibrium, the vector sum of their three force is equal to 0 because it is a vector sum. There are two component equation, one vertical and one horizontal. So the calculation about the gliders application of equilibrium is wake minus to lift cos A minus drag sin A equal to velocity equal to 0. Okay, for vertical, and for the horizontal is drag cos A minus lift sin A. Okay, minus to 0, equal to 0. Okay, where the sign cos trigonometric sine and cosine function. V is the net vertical force and H net horizontal force. Because you are looking at an equilibrium condition, H and V are equal to 0. So for the example 2, we move to example 2. We the picture add a spoiler at the behind of glider. So spoiler is deployed on the top of glider wing, decreasing the lift and increasing the drag. So the wake remains the same. The glider is no longer in equilibrium, so non-equilibrium in the glider. So the equation for the force remain the same, but there are no the net horizontal, the vertical force. V and H are not equal to 0. Okay, the more than according to the Newton's second law of motion, the aircraft will begin to accelerate downward and to the right. For the example, in example 2, the force are not balanced. Okay, not balanced, and airplane is not in equilibrium. So that's all from me. Thank you.